Hello. So this is Qingwu, and sitting beside me is Mohammed. We are Alto co-chair, and so this is so Alto working group session. Welcome to Philadelphia. And for people in the room, actually, if you don't speak, actually, please keep your mask. And if uh, you make a comments and make a presentation, you can take a mask off. Not aware. Probably you already know this. If you're not familiar, please consult with coach, consult with chair and our AD. IETF conduct guidelines, and please focus on technical discussion. Show your respect to your colleagues. IPR disclosure. If you have any IPR, please follow IETF rules. Administrative. So know that this session will be recorded, and we will use media echo for queue control. If you are a remote participant, please join the queue by press raise hand button, and leave the queue by double click. And when you make a comment, please speak your name. And for blue sheet, we have electric blue sheet, and it will automatically record your attendance. And for Jabber and note taker, and we already have Jody and Richard to volunteer. Yeah, so thanks for your taking notes. And so the slides we already uploaded. Please take a look at that. So working remotely, so just remind actually all our discussion actually, most work has been done on the mailing list. Please make a good use of mailing list. We also can schedule some interim meeting if needed, and we actually have auto weekly meeting, and you use IETF working group WebEx resource. So this is our meeting agenda we propose for today's discussion. The first is session introduction and working group status update. And then we'll focus on charter item. We have two important charter items. The first one is auto OEM support, and the second is auto over new transport. For auto OEM support, we'll focus on the status update and resolve the pending issue. And we received a lot of comments before this meeting. Actually, hopefully we can have good discussion on this topic. Second, auto over new transport. We actually, as a chair, we request a review from other area, and we got a lot of quite good quality comments. So we will, take more iteration. We hope also may pay more attention to this auto new transport. Actually, engage with the expert from the other area and to get this worker, because our milestone actually, just a reminder, actually is set on September. We also will discuss deployment experience update. Actually, we actually continued our hackathon. This is our second hackathon led by Jody, and also we have some other people like Ziyang Xing and also Luis actually gave some update for what they are doing, and so we'll have joint presentation for this deployment experience update. If we have time, we will discuss no charter item. Both work actually relate to the computing aware networking, and the first one is consider auto as the network exposure function. Actually, we have three relevant draft. The first two actually are existing draft, just to get updated before the meeting. The last draft discuss auto service function. This is the new draft. So Luis will give the update for the current status. In addition, we have another draft, architecture of computing power optical network Also, this chapter related to the Louis Walker. Maybe we can have some discussion on this. So Sun Zhengjie will present this topic. And so any agenda batch for this? I see none, so we move forward. So document update actually. So first a new RFC, and we since last IT meeting actually we make a lot of progress. Actually, we have 3 RFC get delivered. The first 2 actually are existing working group documents and unified property and CDI request routing. The last one actually the RFC will coming and which just before this before last IT meeting is still individual draft, but after after last IETF meeting, actually we can make a huge progress. Actually, we already moved this individual chapter to working group chapter and also now move to the FCQ and get published. So this shows speedy progress on this work. And second, actually after edit, we still have 2 working group chapter actually waiting for be delivered. Actually, I hope the author can engage with offset editor to address editor requirements and move these 2 work forward. And working group draft, and since last IETF meeting, we adopted 2 draft and OM and new transport. So this will be focus of today's discussion. And errata, actually, this has been discussed in last IETF meeting, already get verified. So this is the current milestone status update. You can see actually we already delivered the one of our milestone cost mode move to for public application. So we get this milestone concluded, and we still have 3 ongoing milestone actually. So please bear in mind the time frame for this each work, especially pay more attention to the auto new transport. This we need to engage more with experts from the other area. Okay. James, James, you can speak. We have James in the queue. Can you speak? No. Okay. Yeah, let's continue. For external review, actually, just we mentioned, actually, we already received other early review and get some more comments from HDB working group like Mike. And so thanks to Mike and Martin and also Spence actually give a very valuable review. So please focus on this external review. So I also want to mention actually, we have auto weekly meeting to discuss cellular information exposure. Actually, 2 relevant work. One is MOVI, the second is the PBECC. And not only testing people are interested in this kind of topic, we also see actually Alibaba and Princeton. Actually, they publish a lot of relevant paper. And so we schedule a meeting to discuss with these experts and researchers actually, for example, Kaya, Jamison, and Ya Xiongxie, actually, also Professor Jennifer, and and they also develop some of open source tools. So these are very helpful to address some of the issue in the cellular information exposure. And also, Tesla Xuelei actually also share some experience on cellular information aggregation. And so before this meeting, they actually post a new version and address some of the comments based on some discussion in the interim weekly meeting. And also Menzili from Alibaba actually share his paper. This paper already get adopted by SIGCOM and which focus on inter AP solution 诸葛. And so we actually agree, actually, we should, for the next step, we should come up with a framework to investigate what set of information to connect, how to transport, connect information to the application, how to react to the information. Hopefully, we can make more progress after this meeting on this topic. Last one, actually, we do a lot of effort to sort of socialize author. Actually, in this meeting, and Luis will, give a presentation in MediOps to introduce their CDN practice integration with Alto, and also actually I will discuss Alto introduction in OPSWG working group, and we already get a time slot on this. And in addition, actually, we chair and work with Alto design team member problems actually to work on some paper which target IETF blog and RP journal. And we will, keep on to cooking this idea to hopefully we can make more progress. So that's it. And I think we can go to the first presenter. Yes, Auto OEM. Yeah. So Jason is not here, and we will ask Maddie actually to give a presentation. So Maddie, come to the mic.
Hello, everybody. I'm Mehdi. I'm here on behalf of the authors of O&M module for Alto. They shouldn't be they couldn't be here in person, so I'm doing the presentation on behalf of them. But the discussion will be guided by Jensen, which is in the virtual room. And the reason that I'm actually focusing on this point because this presentation is intended to start a large part of discussions on O&M because we intend to decrease increase the range of the range that it actually covers into different parts that they will talk about. So O&M stands for Operation O&M stands for Operation Administration, Maintenance, and Management of Alto Protocol. So in this slide, you can see a link to the latest version in Data Tracker and also in GitHub, which is good because a lot of discussions are going on in IETF WGI, Alto WG GitHub, and also the definition of Yang module. Next. So after IETF 113, the group has received many reviews and addressed a lot of them. So we have received 5 reviews from in working group mailing list, and we have an ongoing discussion with NetMode working group. And also we had 5 discussions on GitHub, and we achieved 2 milestones for O&M. And the first one is document adaptation. And the second one is that in hackathon of 114, we have implemented the concepts that are parts of O&M for Alto, which are given in the GitHub link. Okay, so in this slide, you can see a data model overview of the Yang modules that we have included in the draft and also in the implementation. So we have the server management, information resource manager, performance monitor, and logging and fault manager. And we have also data sources inside Yang. We have color coded the parts that are outside the scope of O&M, but inside the scope of Alto, and also the parts that are even outside the scope of Alto, which is like the data sources that are interacting with source-bound APIs with data source listeners. So So in this presentation, we mainly want to discuss 6 main questions and ask comments about them and to further improve one for the next IETF meeting. So the first 3 one have raised within the working group mailing list. Question 4 and 5 have been discussed internally in Alto working group. And the last question is not have been discussed yet, but is an important question that Jensen himself will talk about. And we will divide a large portion of this meeting to decide over that. So next. So the first question is how to deploy data types in Alto related INR registries. And we have 2 proposed models for that, each with its own pros and cons. The first one is to define enumeration in INA Alto types. And it has a pro because it's guarantee consistency between different types. But it has a con that's a major consideration for us, and because it's hard to extend to new data types for experimental drafts. And also it requires INA to have Yang skulls to be to interpret these data types. The second proposition is to use identities in IETF Alto Yang module. And it has a pro because it's easily extensible to extendable to new data types. But the con is it lacks the control for consistency and may result in challenging interoperability between variables. So we are considering which one should we go on with between these 2. The first one was to use enumeration, and the second one is to use identities in the Yang module. The second question is the several level management inspired by RESTConf. We added several lists and we complete several listen stack, which is configurable in the data Yang module. But the remaining question here is that whether we should include configuration parameters of lower level underlying protocols in that too or not. For example, lower level HTTP configurations like cache control or retry after, etc. So that's the main question for this second subject, server level management, whether or not to include lower level configurations. The third question that we try to answer is logging and fault management. So currently in Yang module, we have defined success failure cons for requests and responses. But the reviewers have proposed 3 more logging criteria that we will add in the revision of the draft. The second one is success failure records for the configuration updates themselves. The second one is records for which configuration types is the Yang module supporting, and we were wondering if can Yang module provide this parameter itself or not. And the last one is the status update of the connections to data sources that Alto server is supporting. And we're looking forward to get more suggested useful metrics in the comments discussions or in the experience and of real in the experiments of real deployments. The question 4 is that so far we only have worked for server-side O&M, but the client side also needs an O&M module to be configurable. For example, in these 2 domains, the first one is that how to configure the way that an Alto client is accessing Alto services, for example, the URI, the resource IDs, and the parameters that the Alto client should use to be able to query the Alto server. And the second one is the data model for transport mechanism control with that, to which we will come back later. but there are the three main ways: data polling, pub/sub, or on-demand query, which are very different from each other. And so for this one, the main question that we want to ask comments for is that whether we should add a new top-level container for Alto client or list, or or whether to add a new data source type for Alto server and consider Alto client as an Alto data source listener. So these are very different, and just wanted to ask comments, like if anybody in the queue has a suggestion or in the room, we'd be happy to discuss in this session. Okay. The next major question that we want to answer is server-to-server communication. So we have introduced multi-domain settings for Alto in two major drafts. The first one is for use cases, and the second one is for analytics. The link of these two drafts are given in this slide that you can refer to. But we have faced in the work for through the work for this IETF meeting, we have faced two main questions. The first one is that Alto server sometimes need to be a data source for another Alto server to provide it for network information. So we have two design options here. The first one is to collect data using Alto directly, in which an Alto server can act like Alto client for another Alto server. And that may need extensions to Alto. And the second design option is to use other source-bound protocols to expose databases of Alto servers between multiple Alto servers, and for which we have no standard so far, and need to decide for that to whether be a standard or not. And the second main question here in server-to-server or multi-domain communications between Alto server is cross-domain path discovery, which is a question that we have reached to in the hackathon and in the deployment. So it's a real question. And is that none of the existing Alto services can provide information for cross-domain path discovery. And we actually require some mechanisms to look up to ingress and egress port of inter-domain routes and in different administrative domains to track back the routes between multiple administrative domains. So these are the two questions that we seek answers for. Can you go to the last question that we're seeking answer to is like the one that we don't have an answer for yet, and we want to ask for like most of the comments on this part. So is like how to unify the different data sources in Yang data model and configuration. So we need different data models for different means actually. The first one is, for example, for source-bound protocol stack parameters like URLs or protocol versioning or authentication settings that I previously talked about. The second one is to set the query parameters, the query expressions. And the last one, which is like the most conflicting one, is the data collection mechanism parameters when the clients have the ability to periodically polling the Alto server or use pub/sub mechanisms or on-demand querying. So for this one, Jensen will continue the discussion. So Jensen, if you are in the room, go ahead, please.
Jason, you can go ahead.
Hello.
Yeah, we can hear you.
Yeah, thanks, Matt. Thanks, Marty. So for this question, actually, you see in the current document, we do introduce these three kind of parameters for each data source listener to configure them. But the current data model in the document only define two maximum to collect the data. One is that it can do the periodical polling, and another one is the pub/sub. But in our experiment, in the real development. So with some information resource may need to do the on-demand query for the data sources. So they don't want the data source listener to automatically update the data broker. So the algorithm plugin may want to have some direct access to the data source. So when we're supposed to add a new parameter, the mechanism type is called the on-demand. That means the algorithm plugin don't need to access the internal data broker in the Alto server inside, but just access the data listener to do the direct query to the data source. But this raises some complexity about how to do the mapping between the data broker maintained data structure and the raw data collected from the data source listener. So this is still open question. We want to receive some feedback from the working group or some other members may have some their own experiments on the real deployment of how to handle this. Yeah, thanks.
Yeah, so any comments from the people in the queue or in the room? Okay. You can go on to the next slide. So the next steps for Alto OANM would be that authors will make decisions about question 1 to question 3 that we discussed about as soon as possible, and we'll submit a new version of the OANM document. You can so I think okay, so and also we will continue to collect feedbacks for question 4 to question 6. And also we will test the Yang model in real implementation. So to give you like milestones, the first one is that we will reach agreements on question 1 to question 6, and we'll completely revise the document before next IETF meeting. And the second one is that we want to push Alto OANM Yang model deployment in the current deployment of Alto that we have in Opel Alto GitHub page and before March 23. Thank you.
Martin Duke, Google. Can you go back to slide 5 or question 5? Pardon me. So, why would you not just use the existing Alto protocol? Design, well, like, why not do? What are the drawbacks using design option 1?
So, Jensen, can you go on, like, to answer this question?
Jason, are you online?
Actually, we don't have any documents specify how to really handle the.
You're fading out there. Well, I mean, so like, logically, if you have an Alto server and you want to get the configuration of that Alto server, you ought to be able to use Alto. And that has the advantage of not having like more extensions. Like I don't see why you would need an extension to do that necessarily. But like I would, without looking into details, like architecturally, that would be way, way cleaner than like doing a whole nother design, in my opinion. Thanks.
Okay, so.
Richard, yeah, I think that's actually, I think the comment made by Martin is very, very good. The only small case, which may be the question to Jensen, because you guys and Kai, you guys did the hackathon just like a few days ago, and it was multi-domain. So therefore, if you do multi-domain discovery using Alto, I think you are missing the egress point, which may or may not be interesting to the client. Would that really be an example where you might do one way is like Martin said, which is just extend the Alto protocol itself a little bit, which is very clean by itself. Or maybe you really envision there's some other cases, maybe it's easier for Alto servers to reach agreement because they are essentially enterprise, essentially to enterprise agreement, and then consumer to enterprise. And even for that case, maybe the issue can be solved by essentially some kind of authentication or authorization.
So I think Richard brought up a good point. The egress point is the point that we have reached on when we were implementing the code base for the hackathon. So that's a point that client might not be interested to find out about. So, but Martin's point also makes sense to me because if we should consider some extensions in Alto itself that enables the transfers of this kind of information. But also Richard had another point that I have not an clear answer for that yet. That might be like some sort of communications that between enterprises make sense with some sort of specific authentication or handshake or something like that, and client does not have access to that level of information. So I think that would be the main difference between these two interfaces. But if we realize that we can handle that, we can handle this concern without adding another level of complexity to the protocol, we definitely will go with design option 1 with some extensions.
So I'm sorry, I'm starting to fully process this slide. So this whole discussion, is this like relevant only if, like, does Alto do the currently adopted documents in Alto allow us to do the multi-domain use case? Okay, so this doesn't assume that these other documents go anywhere. I'm sorry, Danny, these two multi-domain drafts. Okay.
Yeah,
Okay.
got your point. Yeah.
All right. Well, I mean, so if we support the multi-domain use case today, then there must be some sort of service discovery mechanism, right, across domains. So that, presumably that would solve the problem. Okay, thanks.
Any other comments about question 6 specifically? Because one of the most complex questions that we are seeking answer to. So can you go to the next slide, please? So this
one?
No, the previous one. So this question is one of the major concerns of the authors. So I'm bringing that around on their behalf. So
I'm sorry, like I was reading the slide and maybe you said it, but like, what is the actual question on this slide?
So Jensen, can you clarify that?
Yeah, we want to see some experiment of how to handle the connection between the algorithm plugin which generate the auto information and the data source listener. So because so far have two approaches. One is that the Alto server can build the internal data broker to store the network information from the data collected from the data source, and the algorithm plugin will use the information stored in the internal data broker to compute the information results. And another approach is that the Alto plugin can directly query the data sources and not to use any data broker. So that's two approaches can happen in different cases, but in the same system actually. We try to find the current approach to define what should be the model to handle this.
Yeah, Richard. So my overall reaction would be, this looks like a very complex issue, right? There's so many different data sources. Are you really sure you want to attack this issue? or maybe to really make a progress, this one can be next round, because you
Yeah,
mentioned a
so
lot
that's
of,
also an option. So we can mention that it's not in the scope of this document, but in the real deployment, that is issue we need to handle. Yeah.
for example, you already talk about quite advanced data sources, and just like a few days ago, maybe 3 or 4 days ago, and Marty and we were talking to Ching Gok, and who is architect of ESNet. We were asking deployment, how to deploy an Alto. Actually, his suggestion would be, can I just send you a file every few minutes? And then you just read it from file and format we can agree on. Then you load into your own server. Would that be simple? So there are a lot of different data sources. Do you really want to? Because my question is, you mentioned servers. I think for the hackathon, you really have all kinds of issues. I think also for the 113 hackathon, and I think we're using G2 mininet. That's a different format. And now you talk about all the, so it's quite large. So that's my main concern.
So I think Richard's comments is like quite relevant here. Sorry, Martin, but for 20 seconds. So we can decide to delegate discussing this question for further improvement after IETF like 115, and focus on like addressing question 1 to 5 before tackling this problem. So that might be a question, but I don't know if you have realized Jensen's comments or not. I think he thinks that in deployments it would be relevant.
Yeah, Martin Duke again. Like this data source thing. I mean, we don't define any of the data source APIs, right? Okay, yeah, and like, I don't know, this idea of data brokers, and I mean, Alto is supposed to be a data source, like the server itself, right? And there's just this proprietary thing where you're just gathering stuff from around the network, and like proposing like a broker that is collecting the data then distributing it to Alto. It's like that's the Alto server. So you're like inventing a new Alto to feed Alto, which, just to zoom out, and again, I'm not a practitioner. That seems like very. I think you're creating abstraction to make this problem tractable. That does not sound very realistic, I guess. And like maybe there may be interesting work in like defining like APIs for data collection, but you would have to get a lot of devices to subscribe to that, and that seems like a big scope increase that we shouldn't get into. Thanks.
Diego Lopez. Yeah, I fully agree with Martin here. I think that going through the southbound interfaces is something that's, I mean, Alto is about exposing data, not about collecting data. So how you collect data, I mean, it's quite important for the implementation and making decisions on the implementation and the design for sure. But making it part of standard probably will be a little bit over standardizing, and this is something that give me the, you know.
So if you don't have any more questions, I can wrap up the comments that were very useful, interesting comments made by Diego and Martin, also Richard. So I think Jensen, answer to this question for you is that Martin and Diego said that in terms of standardization, it's out of the scope of Alto as data aggregation protocol. But in terms of implementation, we can decide later. So all in all, after Richard, Martin, and Diego's comments, I think like we should focus on question 1 to question 5 for the standardization and tackle question 6 only in the implementation afterward. Thank you everybody for listening. I think like we're reaching the end of time for this presentation. So if you have any more comments, we would be happy to have you in the queue for the last minute. Also, we'll appreciate discussions going on the working group mailing list. So please attend the mailing list and please write your comments for us in the mailing list. If possible. Thank you.
Okay, thank you, Martin. Thank you, Marty, and thank you, Jason. Actually, we can keep on discussing the question on the list and prioritize some of the question. Yeah, thank you. Next is about the Alto new transport. Richard.
Okay, so I'm gonna go over the auto transport. Next slides, please. Okay, so here is outline about things which I want to cover. And first one is I really want to show some kind of activities, what we're doing, and sort of for people get a sense about where the modifications come from and where issues come from. And then for people who are new, we do have a bunch of new people who are not familiar with transport protocol. So I'm going to give a very high level, very quick, like 2 or 3 minutes overview about what's going on about new transport, because that's important, or new protocol. And I'll highlight a little bit like a major changes from last IETF and then to the current version. And then I want to spend all the majority of the time and real time to really talk about discussions and remaining issues to be decided. Really focus on the engineering side to really make all the decisions and so on. Next slide, please. So first, a bunch of updates happened and slightly initially a little bit slow, and now we're moving quite like active now. Hopefully, we'll really try to maintain all the momentum and so on. So initially, the document was adopted as a working group document on June 22nd. And then we did a bunch of reviews. Thank you so much for a lot of reviewers, and Louis, Sabine, and Jordi, and a lot of reviewers and from all the group. So give a lot of reviews. And then we finalized submit a new version on July 10th or July 11th, basically between right before the deadline. And now the major issue, as you'll see shortly, which that's why I want to give you a little pointer, would be there are some very excellent HTTP expert reviews. So they are from Martin Thompson, and they're from Spencer, and also from Mark Nottingham. They're very nice reviews, and if you're interested in reading some of the discussions or reviews, and here are the links. And there are also some ongoing discussions, slightly because hackathon delayed a little bit, and now we're resuming. Hopefully we can have all the discussions involved. So next slide, please. Okay. So to really just review a little bit what we're doing in terms of all the requirements, so therefore we can all refresh our memory, because we're not designing a new transport protocol or new auto protocol. Really, whenever possible, is design is let's really make sure that if possible, follow all existing designs, but now using essentially a new transport mechanism, HTTP2 or HTTP3. So therefore, here is a bunch of requirements with essentially that's constraining our design space, and we're not supposed to really invent any new things whenever possible. So basically, number one is like really follow the base protocol possible. So therefore, R0 is request all auto resources possible. I can see that would have some kind of fundamental constraint on the way we design this new transport or auto protocol. And then actually a major base of this one is Alto SSE, which is somehow old technology and server send event, which we borrowed. Initially started from Wendy Room, which is a wonderful designer. And then essentially there's SSE protocol, therefore for requirement inherited from over there, because we want to replace SSE because quite a few people mentioned SSE very important. So therefore this protocol is essentially trying to replace the functions of SSE. So therefore you must be able to request an increment updates. You must be able to stop increment updates. And you must really, the server can tell the client, okay, I'm starting or I'm stopping, sort of give the signaling. And then the server can all have all kind of freedom, really choosing the content type, which you can say later what are major implication and also one of the major design points. We're not going to revisit this point, and they're already determined in the early design, which RFC 8895. And then we want essentially, of course, that's a major decision, and people can discuss. Actually, that would be, I want to refresh memory a little bit for people. And the decision is we're still following the HTTP RESTful API. Actually, that's somehow this requirement actually really bites. Why? Because you can really use HTTP actually to do a lot of things. But if you really want to follow the RESTful API philosophy, and actually this requirement really bites. And in the sense that will constrain the way we design things and the way we discuss. Then, of course, a lot of flexibility of deployment. Next slide, please. To refresh the memory a little bit, so here is the new design in the protocol, and if you have not read the document, it's becoming a little bit longer now. So let me just summarize very quickly and structure, and then we can go to discussions and so on. So the basic design is very simple. You have auto server over there, and you have all the auto information resources, quite a lot now, and we start to collect all kind of information resources, cost map, network map, and endpoint properties and path vectors all start to be used one way or another way. And then what we do is we introduce a concept called a transport queue. You can see over there. And the transport queue essentially have two components. And one is called incremental update queue, and one is called receiver set, RS. And update queue, UQ. And then essentially the user will be connected to the update queue. And also if you want to receive update, you become part of receiver set. And for single user, for example, over here, it's client 2, and you use a single HTTP 2 or 3 connection and to really get updates from multiple update queues. So therefore, that's really the overall design architecture, borrowed a lot from early design. So therefore, that's the basic structure. And the design is client can pull items from update queue, and also the server can push into it. That is in terms of latency or equivalent of push into. You can see there's some like things we want to finalize. Next slide, please. So here is a set of all the major changes. I'm not going to bore you with all the details. Probably they don't make much sense at all, and at this level of things. But overall, you can see that there are a lot of changes, and basically left-hand side is early before the IETF 113, right before 13, and here's a bunch of changes. So therefore, really separate into different sections and make everything as concrete, as detailed as possible. So a lot of very detailed updates and so on. So those are a lot of spec details. Just basically, that's a major progress. Especially all the details according to the discussion of IETF 113 and so on. Next slide, please. So now that's really the design issues which we want to engage, because that's the purpose of face-to-face meeting, and that's really make all the major decisions. So the decision is triggered by very excellent comments and discussions from HTTP experts, of course, because a working group reviews already most addressed, and then we got 3 excellent reviews. So we're trying to address their issues and discussion and so on. So the main point I want to get people to talk about is the phone. And if you worry about, all this discussion would involve a major restructure of the whole document, no, actually we're not. The main thing actually is the main remaining issues raised from discussion, which is excellent, involve essentially 2 issues. One is concurrency control, and one is semantics of the transport. The good thing, actually, the good news is they may represent generic concept for HTTP3 design. Actually, we suddenly realize if for people who follow the email, it's not actually auto-specific. Somehow, it really representing some kind of generic concept. But we want to really get engineering done as specific as possible. And like I mentioned, is remaining issues does not look like really involve major changes, and mostly likely very minor changes, but very important. So therefore, we want the working group to have very careful decision and discussion, and then we can finalize all those things, and then we can make very good progress. Next slide, please. So now let's really talk about the first thing we want the working group to make a decision. And to really present the issues clearly, let's very quickly review the basic concept. So therefore, very quickly, let's review it, then we can really discuss. So what are the basic issues? Here, remember the main thing about new transport protocol, or main thing about actually using HTTP 2.3 or SSE is to do very low latency and very low overhead push of information, network information to the client. The current design in the current document essentially has 2 mechanisms. So let me review very quickly, so therefore we can discuss. One is client pull, and one is a server push. The client pull actual model is a very simple current mechanism. So basically, the client just send a request. For example, and if you look at your right-hand side, and that's essentially the transport queue, update queue status. And for each update, you give a sequence number and with a media type, and we'll also give you a tag about what the information really is. And then the client and you use the same HTTP 2 or 3 connection can issue a GET request. For example, say GET and specify the sequence number, and then we get the content. Very simple and clean. So that's the client pool. Next slide, please. Just refresh your memory. And then here is the ability of server push, which is also well designed. And so let's see what it really is, and then what each we encounter. So here the push is very simple for people who are familiar with HTTP 2. It's using server push promise. So basically, for example, if I'm a server and I want to push a new content, for example, I'll send a push promise stream. For example, push promise stream number 4. You can see on your right-hand side. And I pretend, because the semantics of HTTP 2 really is, that's what I want to follow, is you send a GET request, pretend you send a virtual request. You want to get the client that's supposed to want to do a GET. And then for the sequence number 101, and then server just directly send the content from the server to the client. So that's a server push. It's sort of conceptual. It's like representing a potentially client pool. So those are the basic concepts we're doing. Next slide, please. Now that's the interesting part. So now it turns out that after the very, very interesting discussion, in particular the discussion from Mark Nottingham and is from review is, the question is, if that's what you really want in terms of client pool, and given that for HTTP 2, for example, the load, the client pool overhead may not be as big, why don't you introduce client long pool as a way to solve the issue? That's a very interesting discussion and very interesting comment. So therefore, basically here is one proposal. And what exactly how to get it work? Of course, the email discussion did not go to technical details. And here's engineering. Let's see how it really works. So discussion point is very simple. On your right-hand side, essentially it's transport queue, sequence number 101, 102, 103. But what if you want to get a long pool using HTTP 2? And how to really do that is very simple. Is the client can issue a GET request from the client to the server. and would want to request essentially the next sequence number, which we're building already. So therefore you say, hey, I'm going to get 104. Basically, you always have a hanging or essential outstanding request for next one. So therefore this can be sent without all the TCP handshake and all overhead. You just send using the single connection itself. Then you implement the whole client pool. So therefore that's one feature which we're discussing, and we liked it a lot during our internal weekly meetings. Basically, the only change is very small. We probably add a paragraph, say, okay, and for client pool, and use for the current client pool model. And that's really allow, currently you only can request, which is a sequence number already in the transport queue. And now we should essentially allow, you can allow the current one with sequence number plus 1. Then that becomes essentially the long pool. So that's the design decision 1. Any support? Should I stop here to discuss, or I should just move on, people decide back?
I have a question, but I'd like to save it to the end.
Okay,
Yeah.
okay, because I just, maybe at the end you can see all these points people start focusing. So that's the one proposal. We want to adopt it, but we want to get feedback from working group. Very simple technical change, very elegant, but let's see if we were missing something or somewhere. Next slide, please. Next one, which is also very interesting and also came out essentially from HTTP review, which we really liked. But this one is slightly more conceptual. And actually the change is very interesting, but actually we need a really working group and also all the experts to discuss. So here is the basic proposal about how to do it. So the proposal is very simple and very elegant and in the following sense. For example, remember early part, we talked about the promise, push promise approach of using server push. One very simple way is reverse the thinking of the process. For example, the client want to push, for example, 101, and the client right now the current model is the server will send a push promise, push stream 4, and using the get method and for sequence number of 101 on the right hand side. One possibility is switch the conceptual model. Said, okay, I'm not really server pretending unless you send me a request. Why don't I just really put the content to you? So therefore, you get rid of put promise, and essentially you make the frame into a put frame and put method. You turn the method into put, and now you give a sequence number, you just write into it. So therefore, that's one way of, because why I think there's some like basically there's some discussions from the HTTP review is there's some pushbacks to think about like a server push, which actually interesting they implement themselves in HTTP 203 and as a push promise, but somehow considered as like anti-pattern, and so therefore there's some pushback about like a push. But this one would be more standard. There's no push promise. Everything just become standard HTTP methods, verbs, and put. And so therefore it's very nice. And one additional benefit is if with this one, and actually can get rid of one awkward, which we have in the current document. For example, if people read the document very carefully, we have one place set specified, and for the current implementation design, and the server, the client must not cancel the push promise. Because why? If you push a promise, and then because all the dependencies, there's all the dependencies, if we cancel, it's very hard to really synchronize the state. But if we allow the server to put, the client cannot really like a cancel put. So therefore, would avoid awkwardness. Of course, semantics now really is suddenly the concept becomes somehow used to be that a server would, Alto server would have all the network state and essentially like pushing the information into the client as a cache. But now if you do put, conceptually is now client conceptual becomes essentially a stateful machine and maintain all the state. So that for people who are like a purely, stateful design and HTTP may be resentful. So far we like this one, but we want to have a lot of discussion on this one. So that's the second issue. Next slide, please. So I presume we'll just finish all the issues. Next one, which also actually came out from review and from all three reviewers and Mark and Martin Thompson and Spencer Dawkins. So basically that's the third issue. Basically is they want this discussion is can you, a fundamental what we interpreted is can you just make the HTTP spec as little as possible, ideally we specify nothing. But here is a conceptual issue which we encounter, and that's actually also a generic issue. Let me clarify the issue very clearly, and we want to see which one. So we'll give 3 proposals, and we'll see which one the working group likes, so that we can make a decision. So what exactly the issue, or why even generic issue? When we look at generic issue or specific issue here is look at Alto on your right-hand side, upper right corner. R1 is a network map. You send an abstraction of network. And then you give incremental push update. For example, network map 1, you send a patch 1. So therefore, a data patch, a JSON patch, for example, change the map a little bit. And then you have a cost map 1, which is using network map 1 as reference, because that's we designed the topology and the cost map defining all the costs, and essentially depends on R1. And then you have R4, and which is essentially is a new cost map. which is based on a new updated network map. You might move one IP address from location 1 to location 2, and now you also therefore change the you change also the cost, for example, cost map 1, so therefore becomes like a dependent graph. So overall, actually, is a DAG, what we call direct acyclic graph, of dependency of all the resources, or pushing or sending from the server to the client, either pushing or push. So in the most ideal case, and if the requirement is, hey, if you want to design Alto, you guys, I should specify nothing. So therefore, you just send all the information, ask the server to send from the server to the client. That's easy, called specify nothing approach, engineer approach. So conceptually, just send all of our resources and put into the HTTP2 servers, cache, or using socket API, whatever, and then they just send all of them. So that's design number 1. Basically, Alto specifies nothing, and you map each RI into independent stream, and HTTP just all do all scheduling. The main issue is we might potentially lose substantial performance gain of using HTTP2. Why? We gave all of our resources to the HTTP layer as the server, and because the server doesn't understand about anything about application semantics. So therefore, the server might schedule, let me send R4 first, because they're all in the buffers, they're all like objects. And let me send R4 first, then R3, R2, R1, then essentially the application cannot process anything in the buffer, all R4, R2, R3, R1, until everything is received and then processed. So therefore, you lose essentially the gain of this essentially a dependency. So that's the issue number 1. We did not like that one early design. Therefore, we went down to design 2. But of course, then the issue is we're not specifying nothing. We might introduce maybe over specification and so on. So let's discuss a little bit. In the current design 2 is the form. It also has an issue. It's not perfect, but we are talking about engineering. We're not trying to get everything perfect. We want to get a working version. So in design 2 is the current draft specify that server submits to HTTP transport or the server in a DAG order. So for example, if you're the server and Alto server, you're sending the information, ask HTTP2 to transport for you, and you first really should submit anyone which has no dependency, R1, for example. You just specify, send to it. And then when the for example, is finished, so now the one without dependencies, R2 and R3, you can send R2 and R3. And then you wait until the analyzer says, okay, it's transported, and now you send R4. So therefore, essentially, you really will be allowed somehow their transport in the given order. Of course, by the way, we mentioned this one, even in this one, even though you're sending in the given order, or actually receiver side might also have a semantics. Maybe the HTTP2 client buffer size might still buffer R1, R2, R3, and not delivering upper layer in the right way. There might be still actual delay, but we think this is slightly better. Of course, the issue with this one is also potential issue. Remember, these long-running connections and the TCP window size might be big. Actually, a sliding window of transport might be large enough. We just send R1, R2, R3, R4 in a single shot because they're so big. You suddenly have big buffer, but now we're sending essentially we introduce round trip delay. There's no perfect solution. Okay. Design 3 is actually indicate dependencies. Oh, those resources are really dependent, but that one probably involve modification of HTTP3 semantics or 2 semantics. So we're not targeting this one, but we want to work to make decision 1 or 2. We recommended 2, but we will see what the recommendation really is. Okay, next slide, please. Maybe how am I doing in timing? Am I too slow? Or
You have the timer there.
oh, great. Yeah, I do have time. Great, wonderful. So 3 and is how to whether to specify the settings. That's also an issue which we encountered, and then wonderful point out by Spencer, which is very good point as well. So that's the issue we encountered. So let's see if there's any suggestion or feedback from working group. The current draft, and essentially is we want to control a little bit correct essential specifications. For example, right now in the current draft, we specify that the client must enable the server to say, hey, the server portion is enable, so therefore to be self-consistent. We also want to allow the server and client to really like a limit the concurrencies, so therefore you're not going to overwhelm a very slow Alto client. But unfortunately, we realized, and also very nicely pointed out by Spencer, and is that actually this specification scheme is changed in HTTP3. So basically what happens is setting enable push, now essentially it's kind of now it's removed. If you specify, actually it's an even error. So therefore you really should use like a max push ID frame with conveying information and max concurrency and also change. And so therefore there's essentially 2 and 3 are fundamental to design. So how to handle this issue? One is we just remove them. We don't even specify anymore. We just say, okay, that's operational, and you guys should handle the when you configure your own servers and make sure you configure them all properly, so therefore they're all sending the right way, so therefore we're independent of HTTP2 or HTTP3. The second one is we just specify requirement. You must essentially send the enable push, and you must for example, control this one, but how to really do it will become generic. And then essentially they deploy That's why related with OEM, might need to go in and really send those information relevantly in the correct way. So therefore, either design 1 or design 2, we probably prefer 2, but we want to get feedback from the working group. So that's the next one. Next slide, please. So last one, next one actually might be tricky or might be hard or might be easy. So here is what the question really is. So initially, we used all examples were written in HTTP 1.1 format. Very standard, everyone's so familiar with it. Then we got the feedback that, okay, actually you're really doing HTTP 2. Can you guys now write the format in HTTP 2, for example, that's the right-hand side format. In the middle, I think for some versions, actually we have both 1.1 and 1.2. Then every example would have 2 formats, become very messy. Eventually, we end up with 2. Basically, we wrote all of them with 2, so therefore we give some kind of comments that, okay, send this stream using promise stream number 4. And for example, we just write essentially some kind of like examples and also like some like pseudo instructions to really see how the information should be sent as an example. But a wonderful Sky guide from Mark is actually recommended just using 1.1. So therefore, should we roll back to all examples using 1.1, but adding some kind of pseudo like annotation to indicate what kind of information or not. So therefore, we really need some kind of guidance, and therefore we don't want to go back and forth. We just want to finalize. Next slide, please. So last one is the media type, and we really need to finalize the media type. I think as soon as this one is possible, this also pointed out by Spencer, so therefore we can finalize this media type, which actually we have an internal version already, but we want to wait a little bit until everything is final, and we're going to dump this format into it, which should be relatively quick. But if people have any comments, and we're more than happy to really go back. Otherwise, we're going to use traditional RFC 7285 format. Last slide, please. Next slide.
Okay.
Okay, so here is a list of all the questions. And now we're listening to all the comments and all the feedback from all the comments. Hopefully we put all over there. We want to get people to tell us what you feel strongly to go ahead. Martin.
Okay, Martin Duke, Google. So one minor thing, can you go to discuss 3, please?
Sorry.
So like, I'm in favor of, saying what you mean in documents and not. So I don't know how long it take to find the slide, but whether like to say something, I say yes, say something. Don't just like ignore it and assume people do the right thing. Discuss 3. You overshot, right?
Next one.
Right. No. Okay. Anyway, forget it. So write something down. Like you could just write for HTTP2 and HTTP3, or you could have a generic requirement. I would have a requirement that I would not just say configure your thing properly, because that doesn't mean anything to implementers.
So design option 2, essentially.
Yes.
Okay. But without go to details of HTTP2, do this way, HTTP3, do that way, just as a requirement.
Yeah, I mean, I would just say like make sure you can send enough pushes, or make sure you can send push, assuming you're using push, and make sure you have enough streams.
Okay.
Whatever the requirement is. Okay.
Sounds good.
So to zoom out, well, okay, actually, so one clarifying question. So are you now considering not using push at all?
That's the discussion. So can you go to discussion? Maybe go to
yeah. I mean, there was a bunch.
Very end.
So there were like 5. There were like 4 design options.
4 design options
for how to do SSC. Yeah. Okay.
Go on.
And one of them is push, and none of them are.
Sorry. 1 second. Just 1 second.
Okay.
I can point to it. Make it easy. Next slide. Okay. So basically, it's client pull already. We can support it.
Right.
And server push we can replace with server put.
Okay.
Oh, keep both. Of course, that's probably these 2 are mutually exclusive. So you can say it's either we keep this one. Move. So okay, has mine. And so basically, if we change it into server put and get rid of server push completely.
Okay. So server put exists in 1.1, right?
Server put already exists in 1.1. Yes.
Okay. All right.
That's essentially get rid of push promise.
Right. Okay. So this is interesting. You got the best possible reviewers from the HTTP group. So that was exciting to me.
Exactly.
So like I want to zoom out on this draft. Like
sure.
So first of all, okay. So number 1, the naive way, I think, as Martin Thompson put it in his review, the naive way to do Alto over HTTP2 is just take the requests and put them in streams, like the 7285 Alto, put them in streams, and you're done, right? Including SSC, all that. There's nothing wrong with that.
Correct.
So
that's related to 3, right? Basically, 2. Essentially, some kind of like to basically order and constraint. You don't
Right,
even
so,
worry
like-
about these type of things.
So, I mean, I don't want to, like, we have a deliverable. I don't want to, like, get tunnel vision on a deliverable.
Mhm.
If the answer is that just, like, not having an HTTP2 document is the right answer because you just take, like many other HTTP applications, you just take one, you rip it out, you put it in two,
Yeah,
and it
yeah.
works, and it works better
It works.
because
It works. You might lose some
because-
performance in some cases. Yes, you're right.
right. And I think it's always important to benchmark whatever we're doing against doing that.
Sure.
What I am, and this is a terrible thing to say because it's potentially like really changing deliverable, but what I feel like happened, if I'm understanding correctly, is the HTTP experts essentially redesigned SSE for us.
Yes, in some way.
In a version agnostic way
Mhm.
that maybe was better.
Okay.
And if that is the case, you know, I've been thinking about this for 10 minutes, so this is maybe a crazy idea, but it's like the right answer to do 8895 bis and not have an H2 and 3 document.
Mhm.
Because it sounds to me like if we just do well, I don't know. I mean, I don't know if you've implemented anything or you're still like struggling with the design here.
We currently implemented, I think I mentioned a little bit, actually was on the server push because that was the key feature
Right,
of
okay.
a push.
Fair
And
enough.
now, of course, we got a pushback, which is very soon, only a few days ago.
Yeah.
Well, not a push, basically a suggestion, which is a wonderful suggestion.
Mhm.
We never thought there's a possibility of reverse it. Of course, there's conceptual issues. And
Yes.
some people, you know, always can get like philosophical, no, that's not right philosophy, even though syntax is simple, it's equivalent, but philosophical is different. So therefore, but we're doing engineering as long as
Yeah.
we.
And like, and you know, if any of the suggestions I have turn out to make sense, like I'm happy to push back the milestone deadline.
Sure.
But I mean, like,
For current milestone, actually server push is easier because that's already almost done. Yeah.
no, but
We don't
yeah.
switch to like a server push because
So-
that's philosophically different concept.
So I guess what I'm saying is like some data would be useful here. I mean, I think we have vanilla, like you could take vanilla 7285 plus SSE
Uh-huh.
and just put it in an HB2 implementation with no like special anything.
Sure.
And like you're going to get some performance.
Yeah,
right?
that's serialization. Basically, performance will be horrible potentially. For example, you can
Well-
see that
well,
the
maybe,
more streams
like-
you have, and I can construct cases that make it look really bad.
Okay.
Because they serialize.
Okay, fair enough. All right. Like conversely, you could do push, which I guess you have code for,
Yeah,
and
currently.
see that there's an improvement versus just using HTTP2 by itself, right?
Sure. Yeah.
Or HTTP.
Or you mean to do with client pool only.
Right.
Because basically, essentially, we have model is client pool only, server push only, and long pool. Definitely, long pool should implement. I think
Right.
that's very very elegant,
Mhm.
very minor change. The major concept change debate is: do we really switch the model from the server pushing and essentially virtually putting for the client, or the server just putting the content into the client? Anyway,
would you consider 8895 to be client pull? Is that inaccurate?
85. And then I'm sorry, what's the,
8895, the SSE doc, is that client pull?
it's server push.
It's server push.
But using SSE, which is a method for all kinds of transport because that's
Right.
the only mechanism available. So
Okay.
actually, conceptually, it is server push, not a
Okay.
client pull. It's a server push, not a server put.
Okay, so I mean, this is whoever's the note taker is gonna
Right.
kill me. So I'm gonna like
Think about
stop diving into this, but I would like you to think about. I would like to free yourself of what you're chartered to do for a minute.
Sure.
Think about like what are we trying to solve?
Mhm.
Like, is it best positioned in terms of HTTP versions or a new mode that like replaces 8895 or supplements 8895? And like, so that's like do some thinking. And two, like, given that you have some code, and you know, I know there's not infinite software resources, but certainly like some experimentation to show
Yeah,
that
that's
we-
possible.
that-
We do have server push. We do,
Yeah.
but server push conceptually, But
Mhm.
the good thing, if you're using standard client software like library, it'll be slightly harder because typically clients are not really ready to be written into it. Typically read cache. They're not like a writable cache. Mostly
Okay.
just write it only once. But now put some conceptually, it's more like a data store. So
Okay. So I, like that's my advice to do those two things. And like my thoughts are fragmented, so I'm not going to continue to
yeah,
stand
sure,
up here.
sure.
But if you'd like to huddle offline right after this, maybe we can
Yeah, we should talk about
talk
it,
through
yeah.
a little bit more. Okay,
Yeah.
thank you.
And of course, also discussion two, which is no discussion three. I'm sorry, yeah, discussion two, 1.2 here too.
Yeah, I
That's
mean,
also relevant about how much to specify. If you look at all the discussions, there's discussion about don't specify anything, or maybe there's you can say the case because generic we're solving a case which actually generic HTTP 203 case, which is how to handle multiple dependency and how to give instructions from to the transport layer, which is generic issue. I think that's why Mark actually gave 2 pointers about his own work, other people's work, see if we have any suggestion even to that piece of work, because he can see that essentially there's common like abstraction behind it.
Yeah, yeah. So I mean, I think you've really hit the jackpot with who you're talking to about this.
Yeah, of course.
And I would never dream of second guessing Mark Nottingham about HTTP or Martin Thompson.
Sure. Yeah.
But yeah, let's talk after and see what the right thing to do with this is.
Right.
Like I said, if we need to change the charter, we could change the charter.
Sure.
Because I think we've gotten a lot of great insight we didn't have when we charted this.
Yeah.
Thank you.
Wonderful.
And thanks for working quickly on this.
Thank you. So I'll just.
Thank you, Richard. It's good discussion. Let's move to the next topic. Jody. Okay, take the floor.
So hi, I'm Jordi Rogeral, welcome. And I'm going to be talking about Alto code bases and deployment. This is actually a presentation actually several of us that we're going to be talking about this. So I'm going to be calling out for more people, I guess, to join me. So we can go next, yeah. Yeah, I'm gonna just at the very high level, just recap on the code base architecture, just very fast on project management and approach, and then jump into deployments. And then we're probably going to skip the hackathon because that was presented actually Sunday. So you have the YouTube video if you want to look at that. But yeah, going next. Yeah, so next. Yeah, so yeah, this is a summary of the charter. You all know about it, the history of Alto, starting from peer-to-peer, then CDNs, and recently sort of going into these new applications, a lot of discussions. This is not really in the charter, but there are a lot of discussions about, using Alto for edge computing, 5G, cellular, and others, and participation from multiple vendors and so on. So next. Yeah, so this is 7285, the traditional architecture, and if you actually want to go next here, next, couple more. So yeah, that's how we map it basically. So there's a northbound API, southbound API. The standard focuses on the northbound API primarily. There was just a discussion about the southbound API and not over standardizing that part. But yeah, that's how we envision the deployment of the code base. On the northbound, you have applications across the board from traditional CDNs, but also science traffic, moving global data sets, large scale data sets globally with the science networks, and then the edge cloud applications, augmented reality, IoT, the metaverse, and so on. And then southbound, again, the across the board, going from data centers all the way to the edge as well, and the backhaul. So moving on next. Yeah, just next. This is pretty much what we discussed in the last IETF. So I'm going to just cruise through these, I guess, very fast. But we have an approach whereby we are leveraging the hackathons as checkpoints and milestones to progress. So you saw that over the weekend, the team delivered a demo of integration of Alto with science networks. FTS Rusio, and also multipath quick and MPTCP by Ziyang as well. Yeah, so moving on next. If you're interested, we use Scrum to manage the project, and we have the dashboards available. Everything's under GitHub. It's openly available, so anyone can check anytime. So there's a dashboard for the Hackathon 1/14th, and in general, a dashboard for the overall progress of Open Alto. Moving on next. Yeah, that's just a preview of the dashboard. Next. And just jumping into the topic of this conversation as well. So the Alto deployments, if you want to go next. Yeah, the first part is what's been discussed in the past, the current implementations. There's a wiki available. There's the Comcast, Banox, and Telefonica previous deployments. And then we have a bunch of new deployments work in progress that we're going to be discussing right now, I guess, in this conversation and ongoing. So the Pacific Research Platform in California, then CERN in Europe, but really a global network, UCSD 5G deployment, MP Quick, MP TCP, and then the Edge Cloud and science networks in general. So moving on to next.
Can you go back? What do you mean there's an MP Quick, MPTCP deployment?
Well, I'm going to have Ziyang discuss that, I guess.
Okay.
Yeah.
All right.
Yes. So it's a good question. Some of these, I'll let him answer the question. Some of these are just a work in progress. They may not actually be deployments. It was, so that it might be abusing a little bit the terminology, but yeah. Mm-hmm. Yeah. So, yeah, next one. So, so Richard, actually, you want to take this one? I think there's, yeah, we'll switch.
Okay. Yeah. So this is basically a deployment or essential implementation that we're working with the quite a lot of people. I think some people saw. Oh, wait, okay. Yeah. So for people who follow Alto mailing list, and so this is really is a collaboration between this Alto working group and also essential the CERN team. The CERN team includes essential two teams. Actually, it's relatively complex. Well, actually, quite a lot of teams. It's relatively complex. So one team CERN is the CERN team is Mihai. I think probably you guys saw the email. Alto mailing list has the project lead of the FTS project, which is essentially all the data in CERN will be submitted to FTS system. FTS will do all the scheduling. And also Steve Murray, also part of the system. You probably saw his email as well. And he's the operating manager, so therefore that's one part of. So the question, and of course the other part I think involving in terms of people would be the Ruzu. Ruzu is on top of FTS. So basically Ruzu will select which sources to really transmit, and FTS would collect all the transmission requests and then try to schedule in the right way. So for this one in particular, basically is the main feature is a major missing part about FTS or for the CERN is you cannot really control the bandwidth usage on every single link. So therefore, the main new use case of Alto here, because typical Alto we really consider always like a source selection or peer selection and so on. Actually here for this particular use case, which they found to be very exciting for the CERN is you basically in CERN, the data transfer is you have source, you have destination, and you send the data. So here is we use Alto to really map the source destination, basically to, for example, DTN's data transfer node, and map into the physical links using Alto, using external cost map and path vector to map in the physical links you use. Then application itself, because running app layer, you can really collect all the usage and all the transfers of all like app layer links, and then you compute the total usage every protocol. They do the optimization control every 30 seconds or 1 minute. Then Alto will tell you how much you're using on every single physical link. And then essentially you can really convert into, for example, you say, hey, I want to make sure I'm not using this link and more than, for example, 10 gig, or for example, for these two links, or for these two organizations, for these two experiments, CMS, or for example, whatever standard experiment, and the ratio should be 1/2. So therefore, basically, that's FTS specified resource control goal. And then we implement this all the algorithm, essentially using auto information, is mapping as a constraint. And then we implement a full zero-order gradient algorithm, which is actually quite exciting. And I think we did a demo over there. Then also a composition framework to go from not only zero order, but also first order. And the first order actually is the George's work of bottleneck, of course, right at this moment. And the bottleneck structure is now in the scope of the charter. So most we're focusing on first is really get the information control, which is quite a new interesting case. We're hoping to, you guys probably saw the email on the auto mailing list. So the goal is really get the production, and I think mailing list from both Mihai and also from Mario. So it's really get the production data and see how far we can push.
So is this is this informing a network management tool that's then reprovisioning the network based on this data, or is this a client-oriented service?
So I don't know what means a client also. Basically, the workflow is following. FTS actually centralized control, logical centralized. Of course, if you want to read separate, you might be able to separate it. So basically, there's a centralized controller running a hoster, basically. You might run multiple. And each one actually would have a huge database to get all the transfer requests from across all the data.
Okay.
And this guy would essentially become auto client to really get the data from the ESNet, from all the networks, to really map from, for example, I'm sending data from MIT to Caltech. I'm sending data from Stanford to CERN. So therefore, you map into the physical links. And then this query by query auto client. And then this server, centralized logical server, will do the optimization, do the constraint himself. So I don't know if that's probably that's from that's a server-based approach. Logical centralized, of course, they're all kind of make it scalable, separate into different like partitions and so on. But overall, this is like logical server control, but only using auto client.
Okay, so the network management, the optimizer is acting as an Alto client to extract the information. Okay, that's
and
interesting.
optimize every 30 seconds or 1 minute. That's a production code.
Okay. All right. So the user of Alto is like the network manager itself. It is not like some person trying to download data.
For initially, right now we're really using some like data, and we had a discussion with Ching, and I think we're also going to have a very quick meeting with India Munger, who is the director of the ESNet, which is the US part of this infrastructure. And initially, that's why I asked a question that initially actually Ching's suggestion from last week is, can I just give you a file and then that's your data source? You just load your auto server and then send to
Yeah. Okay. Thanks.
Okay. Thanks, Richard. Moving on to the next one. Yeah, we can actually move on to the next one. So, yeah, we're going to move to the next one. So there's a paper that's going to be published at SIGCOMM on this deployment as well. And we'll put another demo in the next hackathon 114 as we continue to progress on that deployment. Yeah, the next one is actually Alto Telefonica deployment. So Luis.
Yes, hello. This is an excerpt of what will be presented on Friday in the Media Operations Working Group. So it's the integration of the Alto in the Telefonica network in order to expose the capabilities to the Telefonica CDN. Telefonica CDN is an in-house development by Telefonica, so it will be the client of the information that will be provided by the Alto server in essentially collecting the information from the Telefonica network. So what you can see here a very basic example. This was some tests in the lab. So we are now in the process of moving this into the production network. I will show later. So essentially here, what we identify is we assign PIDs for the streamer, the CDN streamers, and also we have PIDs for identifying or collecting, let's say, the prefixes of the customers of Telefonica networks in the different central offices, in the different POPs, right? So the request routing logic of the Telefonica CDN takes into account a number of inputs, no? The streamer status, the load level, and so always from the perspective of the CDN. So the idea is to complement this with the perspective of the network, where the customers are in principle, so in such a way that we can determine what would be the number of hops right now with the capabilities of Telefonica, of Alto that we are playing with right now, simply the number of hops from the streamers. The idea would be to enrich that information with performance metrics and all the capabilities that are being developed in Alto in general, right? So essentially the point is with this information, the Telefonica CDN will consume the topological information, identifying where are the preferences of the customer, and then taking decisions not only based on the server or the CDN streamer information, but also on the network information itself for taking the best decision at the time of delivering the content. Next, please. So this is the process that we are following. We started with playing with Alto in the tenology lab. So essentially very basic setups. I will detail later on as well. So very simplistic network just for understanding the capabilities and the feasibility and viability of this approach. Then we moved to the pre-production lab, facing real configuration of the network and the complexities that I will detail. And the point where we are now is just previously to introducing it into the production network. So we are fighting with all the rules about security, hardening the server, and so on and so forth. So the idea or the expectation that we have is to, during this summer, to go into production. And I hope to be able to report in next IETF the results that we can collect. It's important to, in all the pre-production lab and so, we are playing with the real configurations, but we don't have the good insight about the scalability and so. So once we move into the production network, we will get more stats and more information that we would like to share with all of you, just to see what is a real deployment. Just for you to understand, when we are talking about the real deployment, this would be maybe the idea would be for Alto to handle around 3,000 routers or something like that. In pre-production, we are talking about 40 routers, something like this. So the next step is basically to understand the scalability and all this stuff. Next, please. So this is the very last slide. I would like just to comment what was somehow the technical problems that we faced and somehow the different engineering fights that we have with this deployment. In the technology lab test, essentially we started with the Alto module in Open Daylight. We need to adapt that because, well, Open Daylight module was based on an LDP, so there was some transition to start collecting information from BGP. In the technology lab, we face a mono-vendor router scenario with virtualized routers, so something somehow a lab environment for sure. Simplistic network configuration with just single IGP or SPF in this case, single autonomous system, and simple metrics like the hop count, right? And Alto was connected essentially to some of the routers acting as route reflectors, so very constrained environment. Then we moved to the pre-production environment. We migrated from the BGP module from ODL to the EXA-BGP. We started finding issues in EXA-BGP. We raised a number of tickets that have been already solved, especially for BGP-LS. So I mentioned later, okay. In this pre-production environment, we started playing with multi-vendor environments, multi-vendor routers, physical routers, so moving from the virtual to the physical, dedicated Alto server, and also facing the complexity of the real network for the particular affiliate of Telefonica where we are doing this test. This is a network that has multiple private autonomous systems and also for sure public autonomous system. They also, it's a network that is not a IP continuum, it's an MPLS continuum, so facing different issues in this respect. Also combining OSPF and ISIS. And we started also to take into account more sophisticated metrics in IGP. So not only the number of hops, but essentially the metric that is being defined in the IGP for building the cost map and the network map. And then also connecting to different route reflectors, one for BGP sessions in order to collect the IP prefixes of the different customers in the different POPs of Telefonica, and another route reflector for BGP-LS in order to retrieve the topology and being able to build the network map. Okay, so the very last steps is the integration with the production network. So we are now in the process of being adapted to the production processes and rules, the security, the addressing, the internal routing of the network, all this stuff that you can imagine. So hardening all the environment in order to protect from external attacks. The point now in the production network, in the routing part, is that the activation of BGP-LS is limited. So we will start with a region of the network, and then we will start progressively activating BGP-LS in the rest of the network in such a way that we can incorporate all the information step by step. Then also helping us to understand the scalability aspects and so. And well, we will coexist with many other services for sure. And the expected deployment is to complete the deployment for Q3. So we're trying to bring here in IETF 115 the results for all of you. That's all from me, I think.
Yeah, Luis, I have just one question for you for what you have presented so far. So yes, thank you for sharing this interesting data, which is really showing that there's something which is really concrete and really happening with the protocol. So I really invite the others who has experience with the protocol to share with that. So I understand that you have, I would say, some of the issues for the integration and so on, which is just, I would say, as expected. So if we just focus on the pure Alto, I would say, specification and so on. Did you encounter so far, I would say, any missing parts or something that needs to be clarified in the specification itself that need to be more input from the working group, or it's just business as usual?
We felt to expect business as usual. So the most problematic thing was to parse the information from the protocols of SPF, ISIS, and so. So no special issue with the fact of building the network map and the cost map. This was more or less straightforward. It was basically the parsing of the protocols and trying to expose, let's say, the information of the network to be digested by Alto. Once this was solved, the process of Alto was straightforward.
Yeah, and for the performance perspective, for example, how Alto is behaving, how the request, and is there any, I would say, shortcoming in the way the operation of the protocol is currently designed? Is there something that, for example, enhancement that we can consider in the future? I think that is important. This is for me the key part that we need to focus on. And if you have input, that will be really appreciated.
Yeah. But by now, not anything special. So take into account that we are in pre-production. We are leaving the pre-production for moving to production. I'm sure that in the production we will face more complexities because the network will be huge. By now we are dealing with 30, 40 routers. Is something feasible. Regarding stations or considerations for Alto, yeah, I think that the next step would be to include performance metrics on top of the picture. So not only taking into account the hubs, not only taking into account the AGP metrics, but also taking into account the situation of the network in such a way that the selection of the streamer could be richer in the sense of not only considering the path, I mean the length of the path, but also the characteristics of the path. So this is the next step. Okay. We have a number of use cases on mind. Probably is soon for this talking. So we are concentrating on the deployment, but the idea would be to enrich the decisions at the end.
Okay, and one last question on this one about the bootstrapping and the configuration. I would say how you are automating the way the various engines are currently running. Do you have?
But now it's something manual. I mean, we need to somehow we are in a phase of how to say being sure that this is, we are sure that this is the way to follow, but the next step would be to integrate this with the logic of the CDN. So automating all of this from the CDN perspective. So in such a way that we can retrieve automatically and frequently and so the information from Alto. Yeah. So from Alto to the network, no special, we don't expect special things. It would be more from the client for the TCDN, the Telefonica CDN towards Alto to automate all the process to select the streamers and so on.
Okay, thank you, Luis.
Thank you.
Okay, let's move on. I think we need to.
Yeah, I know we hit the time limit, right, for this one.
For next one, actually, do you want to Xiang or you want to?
So I was going to talk a little bit about the PRP deployment.
Okay.
So just real quick. So the next one. Yeah, just to put things a little bit in perspective. So Richard talked about CERN, which is the problem of the large-scale data transfers from CERN to globally to scientists and research labs around the world. Now we're also looking at another deployment at the Pacific Research Platform right here. But in general, the idea is that there's interest in expanding through science networks. So we're also collaborating with ESNet, also in the PRP deployment. And as Richard mentioned, we're meeting with Inder Monga, executive director of ESNet, to discuss these deployments. This is a family of science networks that their architecture is shared. So if we deploy Alto and Show Value, then it can be deployed in the rest of the networks as well. So that's an approach and the potential upside here. So next one, just real quick on this the PRP is what these networks are doing. Also, they are extending to the edge. So they're actually extending the networks onto the 5G domain and building the edge cloud as well, whether it's the Department of Energy ESNet network, building sensors and collecting that through wireless, and then building the 5G edge cloud. And an example is PRP that's building a 5G edge cloud at UCSD and other universities, NYU and other universities in the US as well. And so they're looking at applications like the holodeck, vehicle networks, and in general, the metaverse or augmented reality. And so in this project, there's an ecosystem of collaborators coming in. There's Caltech, ESNet, and PRP and others, and Qualcomm is actually involved here as well. And so moving on to the next one. Yeah, and this is about closing the loop here, building what we call sort of the edge loop. So from a network, you have first visibility, then you apply intelligence, and then control back to the network, and this orchestration as well. We believe that Alto is suitable for visibility, and that's the deployment here. The PRP basically is building this architecture and has Alto as the element to enable this visibility. Here in the intelligence, we're looking at putting bottleneck structure analysis basically to be able to make optimize decisions, whether it's routing or rate limiting or service placement. And then controllability could include technologies like segment routing and others to help steer the flows. So moving on to the next one. Yeah, and so that's just, then the next one, I don't know if we have time for Zian to make some.
Yeah, maybe we can.
Just a note on the PRP, we're going to be putting a demo in the next hackathon. That's the goal for that deployment, and also at SC22, also in November in Dallas.
Do you want to skip this? Or
Zian, you're available? Yeah. Or?
So Zian, are you online? Do you want to present? Have a quick, maybe 2 minutes to have a quick.
Okay. I will introduce my project. We know in the default mode, SDN controller only select one path every time for MP Quick and MP TCP. There are lots of paths not working in the SDN. So my idea is keep all the paths working by ALTO. So my serve is collect network status, and the ALTO climate is the controller in SDN, and I allocate MPTCP and or MP Quick packet to suitable paths. So I did the test in Open Daylight and Mini Night, and also in MP4 and IP6. Next page. So the result is that the throughput of MPTCP IP Quick is higher than without ALTO, especially in per network. We can see from the picture, loss rate higher, the throughput before is now. Thank you.
Okay, thank you, Zian.
And then you have the IETF Hackathon 114. We can take this offline, I guess. This is YouTube recording you can access, and there are the slide decks from yesterday, actually from Sunday. So I think this concludes this talk. Thanks.
Thank you. So next, we'll have Luis to give a presentation.
Thank you, Tim. Yes, this presentation is, I will cover 3 drafts. The overall idea, the working idea is to consider Alto as a network spatial function for IETF technologies. And we will cover the drafts that you can see listed there. And I will do on behalf of my co-authors, Danny, Christian, Sabine, and Shufeng. Next, please. So in order to present the relationship among these drafts, the overarching one would be the one which is entitled IETF network spatial function. So the idea is to consider Alto as playing this role of the spatial function that is able to expose capabilities of the network to applications, external or internal applications, such a way that can consume what the network can provide. What kind of information can provide the network? Here we have the 2 examples that are the other 2 drafts involved, but will be many others, right? One example could be, for instance, to determine the more convenient compute environment for instantiating any kind of application, functions, or whatever. This is covered by the service edge draft. So essentially, thinking on exposing compute capabilities, CPU, RAM, storage, and so on and so forth. The other draft, the one entitled service functions, follows the same approach, but with the idea of exposing where service functions are and also the characteristics to reach those service functions. Here we can consider isolated service functions, or we could consider even service function chains. So in such a way, the idea would be, the objective again would be to characterize the path to reach these functions, or to compose, let's say, the service chain among those functions. In the others, there are, well, I will comment specifically on the NEF slide. So we will start with the NEF, the overarching document, then following by the service edge. These 2 have been already presented in the past, and I will focus later on a little bit more on the latest one, the service function, which is the new to be presented here. So in the IETF network spatial function, the current version is 0.1. This is the intention, again, is to align this with the current industrial trend of network application integration. And there are similar initiatives in other SDOs. And here we can consider, for instance, the 3GPP network spatial function. That somehow is the inspiration of this work. Also the MEC APIs, the ORAN RIG, the Linux Camera initiative that is very recent, with the idea also of offering APIs to request and consume capabilities of the network, and so on and so forth. So again, the problem statement is very easy. No? The networks are becoming consumable by application and services. So let's consider Alto as the entry point for that exposure capabilities in which respect to IETF network technologies. So the final objective is that the applications can make informed decisions, taking into account the network information. So no blind decisions as could be as today. So as today, applications are inferring or are guessing characteristics of the network. So the idea would be, okay, let's ask the network, and the network will provide this information in such a way that I can, at the end, take an informed permission, an informed decision, and then improve the quality of experience, and so on and so forth. So in this draft, this is, as I said before, it's a kind of overarching draft. So trying to expose what would be the different kind of capabilities to be exposed. We are considering by now existing capabilities, for sure, the topology and the cost map. And so this is somehow the initial capabilities of Alto, but also the performance metrics, the segmented view that can be provided by the path vector, and so on and so forth. And also we include in this draft proposed some other proposals as the service edge, the service functions, the abstraction of underlay for the overlay, and this will work for the cellular, for the CDN, for the SD-WAN, and some other situations that will emerge or are emerging in the industry, like the emergence or the appearance of the dynamic IP pools because of the fact of separating the control plane and the user plane, both in the mobile part, but also in the fixed part with the BNG disaggregation, the CUPS approach. So the updates in version 0.1 for this draft specifically has been the content about service functions that is detailed in the draft that I will comment later, and also security aspects that were not present in the previous version. So next one, please. So this is the draft about service edge. The current version is 0.5, and this activity or this draft somehow is related with the compute aware networking discussion that is happening in the routing working group area. But from in the case of Alto, what Alto can provide here is an off-path solution. So the routing working group area is working in an on-path solution. Here we are addressing the same problem space, but with a different perspective, with a different approach. So the problem the statement is also clear. There are multiple and heterogeneous data centers being deployed across the networks. So there are compute capabilities in terms of CPU, storage, bandwidth, memory, and so in different points of the network. So the objective here would be to expose all of this together with the topological information of the network, and in the future with the performance metrics and so on and so forth. The purpose of this would be that the applications that can consume this information can instantiate the applications of the service with informed information about the resources that are available, but also the characteristics of the path to reach those compute capabilities across the network, right? So the solution is to leverage on Alto for aggregating all that information and for exposing this information to the external applications. Again, once more time, in such a way that the application can do an informed decision, no guessing about the characteristics of the network, but just collecting the real information from the network. The updates that have been provided in version 0.5, we describe potential extensions for path vector and unified properties. So the idea is to leverage on the existing work and augmenting that existing work to cover what could be the information related to the computing environments, okay? And we also provide example queries provided for filter entity property map. So providing some examples and so on. So moving to and I will detail a little bit more this last draft. This is about service functions. So the problem statement essentially is that nowadays, the services are formed by a concatenation of service functions. So these service function chains, right? So we have a connected graph of service functions, but by now we don't have a combined information between the functions, this service chain, plus the characteristics that connect these different service functions for the characteristics of the chain. So there is typically more than one instance of a service function in the network. So there is a problem about what service function instance to select individually or to form a chain, to form a graph. So at the end, the purpose of all of this is to help on the service realization by selecting the most suitable service function instance or instances, depending if we are addressing just one single function or a chain of service functions. So at the end, the purpose of this is to characterize the path to reach a particular service function instance or a type of service function. So we could have several instances of the same type. So we can try to determine what would be the better characteristics in the network for reaching one of the instances. And also to characterize the path among a sequence of service functions. Again, I mean, to characterize the path in a service function chain. Next, please. So the kind of information of interest that a client could consume would be well, here list, I will comment some of them. Path characteristics from a PID, I mean, from an endpoint to an instance of a service function type. The same path characteristics from an endpoint to a specific instance of a service function type, or the path characteristics for a given chain, or or at the time of composing a service from one service function to another service function, and so on and so forth. I will not waste more time on this. So there are several cases that could be favored, let's say, for complementing the information with the network information in place. Next, please. So the kind of solution would be similar. The picture is similar to the case of the service edge. So essentially, to combine and to complement, to use the Alto server to integrate the information of the service functions and integrate all of this with the topological information retrieved by BGP, BGPLS, and so as we saw before. So we are proposing here in this draft a number of extensions to enable the Alto clients to request information of interest, the kind of information that we show in the previous slide, and also extensions to collect and combine both the service function and the network information all together for enriching the decision of the service function chain. There are extensions, or we do foresee extensions that could involve augmentations of the path vector and the unified property drafts. So we will leverage on existing work for this. And just to remark that there is a clear link with related activities in IETF, like the service function chain activity, the service programming with segment routing in a Spring Working Group, or the service function our TE topology and TIS. So we see clearly this link with this work in IETF, but also there is a clear link with activities outside IETF, as would be about virtual network function graphs in Etsy NFV. Next, please. So just for finishing the next steps, so clearly this is our idea is to work on these different aspects for the future Alto rechartering. So we have clear that this is for future rechartering. So we want to provide all this work for directing, let's say, the future rechartering in this direction. So our idea is to complement also this other work in other working groups from IETF. So helping on the automation of the service functions or the instantiation of the service functions and so on so far. So we see this as a complement of which is already in other working groups. And our idea is to prepare updated versions of all the documents for IETF 115. And for sure, comments and feedback is more than welcome. So, Martin.
Hi, Martin Duke, Google again. I'm not going to bother with the queue because nobody. I was very excited to see on like one of those slides that like you think there's something worth doing without any extensions. I think that was actually going to be my question, having reviewed this draft before the meeting, because to me, like I think the hump is just to get adoption of this thing, of Alto and out, deployed and servers, real servers and clients out there, and then we can talk about extensions. At this point, like doing extensions is the hope that somebody will adopt the use case is where we've failed a bunch of times, and I think this is very promising in that respect. So good luck to you to get this out there, and I think if this does get out there and deployed, then any extensions that use case might need would, in my mind, move very close to the front of the line for rechartering. Thanks.
Thank you.
Yes, sir. Diego Lopez again. just a remark on what Martin has said is precisely that from my memories of what the guys in CERN and in general in the academic networks are doing, this SFC case would be of interest to them as well, because precisely one of the things that they were interested in to do some kind of messaging of the data before it arrived the final. So probably this could be something that we should offer to them as well, not only for the. It's simply an idea that came to my mind while we were watching what you were saying.
Noted. Thank you, Diego.
Okay. Thanks, Luis. So we have time. So let's move to the next one. Actually, we only have 5 minutes, and so who? Sun Zhenjie. Okay. Daniel Huang, who will take over the last talk? So, Liu Sun, do you want to present this?
Hello, everyone.
You only have 5 minutes.
Okay.
Yeah, 2 minutes.
I will quickly. Hello, everyone. Next, I will introduce the draft called the Architecture of Computing Power Optical Network. Next one. Motivation. With the rapid popularization and application of cloud computing, artificial intelligence, and other technologies will cause the total amount of data has increased explosively, and the demand for data storage, computing, and transmission has increased significantly. Therefore, the processing of these data needs ubiquitous computing power to support. Therefore, with the advantage of ultra-large capacity, ultra long distance, low latency, and flexible scheduling, optical network provide a wide coverage, flexible and efficiency, super capacity, guarantee for computing resource. This architecture combines the computing related network with the optical network to realize the concurrency linkage between the next one use case one network resource acquirement. The edge the edge network management layer receive information from the client, obtains complete user information and provides it to the cloud management platform for network resource. The cloud management platform obtains regular information about applications and networks. The architecture of computing power optical network is shown in the following picture. It includes cloud management platform, computing power orchestration, computing resource, computing power scheduling, cloud network management, edge management platform, edge computing power orchestrating, computing resource, computing power routing and forwarding, edge network management. Next, I will introduce the functions of each component module, the architecture, 那个什么 edge management platform receive application requirements from users were filing the users forward requirements to the cloud management platform. Edge network management reports network information and computing power scheduling information. Cloud management platform, its function includes report the network information to the computing power scheduling layer, inform the computing power serves and perceives the computing power statement through the computing power scaling layer, generate the computing power route and monitor the route in real time. Send the generation computing power arrangement information to cloud network management. Cloud network management distribute the received computing power arrangement information to edge network management. Thank you.
Okay, thanks, Liu-Shen. Actually, we run out of time. Actually, I think this topic also related to the Louis draft. So I encourage the author to, raise some discussion on the list. Engage with Louis for this topic. So let's actually we wrap up for today's discussion. This time and we both attend in person, so it's it's good time. Actually, we get together. Hope everybody we can have more people to attend in person in London meeting. So see you in London meeting. So and Martin, do you have anything to add? No, nice work. Thank you. Okay, thank you.